Hello, this is Mrs. Sargent, and this is lesson 4.1, Formation of Ions and Ionic Compounds. So we have two atoms here. One says, I lost an electron, and his friend says, are you positive? First, we need to start with some terms. The first term that you need to know is ion. An ion is an atom that has a positive or negative charge. So it just means that it's an atom that is carrying a charge. And we get that positive charge by losing electrons and the negative charge by gaining electrons. A cation is an atom with a positive charge. This is created by a loss of valence electrons. An anion is an atom with a negative charge created by a gain of valence electrons. This is how I remember the difference between a cation and an anion. Cation, I think about cats. They're nice and warm and fuzzy, and they give me positive feelings. Now, if you've had a traumatic experience with a cat, that won't work for you, but this works for me. Anion, if you switch the A to an O, it looks like an onion, and sometimes when I cut onions, I cry, and I think about crying as a negative feeling. So that's how I remember the difference between cation and anion. Something else that we need to talk about is this mnemonic device. Leo, the lion, goes grr. So Leo stands for loss of electrons, is oxidation, gain of electrons, is reduction. The octet rule we've already mentioned, but in a little bit more detail. The octet rule says that atoms react by gaining or losing electrons to acquire the stable electron structure of a noble gas. This usually means having 8 valence electrons. Noble gases have a full octet of 8 valence electrons in the outermost S and P sublevels. Or the highest energy level in the S and P sublevel. The only exception to having 8 valence electrons is for hydrogen and helium because they're only going to have a total of 2 because the first energy level can only have 2 electrons. Noble gases are very stable and they do not react with other elements because they already have 8 valence electrons. They don't need any. So the number of valence electrons, remember we wrote these numbers in on our periodic table, and if you have not yet done so, you're going to want to do it. You have the 1A through 8A groups, and that number in front of the A tells us how many valence electrons are in that group or family. The charge of the ions, or the oxidation number, comes from losing or gaining electrons. So like I said, if you don't have the 1A through 8A groups on your periodic table, you're going to want to go ahead and write these in. You are not able to write in the charge of the ions or the oxidation number and use that on your quizzes or tests. But everything in hydrogen's column here has one valence electron. To get to 8, it's going to lose that valence electron, giving it a 1 plus charge. In beryllium's column here, they have 2 valence electrons. They're going to lose those to get a 2 plus charge. Boron in the 3A group is going to lose those 3 to get a 3 plus charge. We're going to skip over here to nitrogen. It has 5 valence electrons. To get to 8, we're going to gain 3, giving us a 3 minus charge. 6A column with oxygen, we're going to gain 2 electrons for a 2 minus charge. And then our halogens in the 7A column are going to gain 1 to get to 8. And so that's where our charge on our ions comes from. This is also referred to as oxidation number. Those go hand in hand and mean the same thing. So potassium is in the 1A column. It's going to have 1 valence electron. Bromine is in 7A, so it's going to have 7 valence electrons. Phosphorus is in the 5A column, so it's going to have 5 valence electrons. And gallium is in the 3A column, and it's going to have 3 valence electrons. So now we need to determine, is it going to lose or gain electrons in order to get to 8? So potassium has 1. It's going to lose that 1 electron to get to 8. And when we lose that 1 electron, it's going to be positively charged, and that means that it's going to be a cation. The oxidation number, or the charge, for potassium is going to be a 1 plus. The ion symbol for potassium is just this symbol for potassium, and then the oxidation number of the charge, so K1 plus. The 1 is not always written. Sometimes you'll see this just as K plus. Bromine has 7 valence electrons. To get to 8, it's going to gain 1 valence electron. When we gain 1, that's going to give us a negative charge, and that's going to make it be an anion. The oxidation number for bromine is 1 minus. The symbol for a bromine ion is Br, 1 minus. Phosphorus is going to gain 3 electrons to get to 8. That's going to be an anion. And then our oxidation number for phosphorus is going to be 3 minus. The ion symbol is going to be P, not B. P3 minus. And then gallium has 3 valence electrons. It's going to lose those 3 electrons. That's going to give us a positive charge, making this a cation. Gallium's oxidation number is going to be 3 plus. And so our symbol for a gallium ion is Ga3 plus. The electron configuration for neon. This is the normal full electron configuration. We're going to start at home, start at hydrogen, 1s2, 2s2, 2p6. The symbol for neon is Ne. And our dot structure is going to start with the symbol. We're going to look how many valence electrons do we have. It's in the 8A column, so it's going to have 8 dots on the dot structure. In your practice, you're asked to mark the valence electrons on your electron configuration. I told you that the valence electrons are found in the outermost S and P sublevels or in the highest energy level. So our highest energy level here for neon is in the second energy level. We have 2 electrons in the S sublevel and 6 in the P sublevel to get our total of 8 valence electrons. For a fluorine atom, we're going to start at hydrogen again, 1s2, 2s2, 2p5. The symbol for fluorine is F. Our highest energy level is the second energy level. We have 2 valence electrons in the S sublevel and 5 in the P sublevel, giving us a total of 7. You can also look at your periodic table. Fluorine is in the 7A column, so it's going to have 7 dots on its dot structure. Let's skip down here to the aluminum atom and then we'll go back to our ions. So the aluminum atom is 1s2, 2s2, 2p6, 3s2, 3p1. The symbol for aluminum is Al. Our highest energy level for aluminum is our third energy level. So we have 2 valence electrons in our S sublevel and 1 in our P sublevel for a total of 3 valence electrons. So our dot structure is going to be Al with 3 dots on it. So these atoms are no different than what we have been doing thus far. For a fluorine ion, it has 7 valence electrons. It's going to gain 1 valence electron to get to 8. So our electron configuration is going to be 1s2, 2s2, 2p6 to indicate that gain of the 1 valence electron. But this looks just like the neon atom. So now we need to put it into ion notation, which means that we're going to put brackets around the electron configuration, and then we're going to put the charge in there. Our valence electrons are in the outermost energy level, so we have 8 for our fluorine ion. The symbol for a fluorine ion is going to be F, and then it's going to have the charge, 1 minus. In the dot structure, we also have to indicate that gain of 1 valence electron. And so it is going to have 8 dots on it. And then we're going to put that in ion notation with the brackets and the charge. For an aluminum ion, we're going to lose these 3 valence electrons. So our ion electron configuration for aluminum is 1s2, 2s2, 2p6. We have to again put it in brackets for our ion notation, and then put the charge. Since it's losing 3, it's going to have a 3 plus charge. So our symbol is going to be Al3 plus. For our dot structure, we're losing these 3 valence electrons. So our dot structure for an aluminum ion is just going to be Al. It lost those dots. And now we just have to put it in ion notation with the brackets and the charge. 3 plus. So how do sodium and chlorine form salt? Sodium is a metal, chlorine is a toxic gas, and when they react together, they form a compound known as sodium chloride, which is table salt that we put on our french fries to make them tasty. The orbital diagram for sodium is 1s2, 2s2, 2p6, 3s1. The chlorine orbital diagram is 1s2, 2s2, 2p6, 3s2, 3p5. So sodium is going to lose its 1 valence electron, and it's going to come over here then to chlorine to fill chlorine's outermost energy level, and giving chlorine a 1 minus charge. So now both sodium and chlorine have a full octet in their outermost energy level. And when they do that, those oppositely charged atoms are going to be attracted to one another. A couple other ways that we can see this is in the dot structure. Again, sodium is going to lose its 1 valence electron. That is going to come over here to chlorine. So chlorine is going to be 1 minus, and sodium is going to be 1 plus. The easiest way I think that you can see this, though, is in the Bohr models. Sodium lost the 1 electron in its 3s sublevel, giving it a positive charge. Sorry about that. And then that 1 valence electron is coming over here to chlorine, giving it a 1 minus charge. And these two atoms are now attracted to each other because opposite charges attract. So an ionic bond is simply a bond that holds oppositely charged particles together in an ionic compound. The elements involved in an ionic compound are metal cations and nonmetal anions. Our metals tend to lose valence electrons, so they become positively charged in our cations. Our nonmetals tend to gain electrons and become negatively charged, meaning that they are anions. You need to work on practice B in your packet. Thanks for stopping by.